Hi everybody. Even though we studied parametric equations and vector equations separately, they're really just two sides of the same coin if you step back and think about it for a second. For parametric equations, we have an equation for x for some input and an equation for y separately. For vector equations, there are two separate places where you can put a mathematical expression that tell you x and y separately. It's just that we have put them both together in a single expression for the vector. So for example, if I want a single point, if I say x equals 3, y equals 4, that corresponds to a single vector that's 3, 4. So those would be the same. I just took my x coordinate and put it in the x spot, y coordinate in the y spot. Obviously, these are constant, so those don't change with time. So what if I wanted to have a vector that scales with time, like this? Well, you know that that vector is the same as if I distributed the t in. So that's the same as 3t, 4t. And then I could just take each of these parts and separate them into their own separate equations. So that's like saying x of t is 3t, and y of t is 4t. So hopefully with these simple examples, you're starting to get the feel that if you had some parametric equations, you could just take the two separate equations and package them together into a vector. Or if you have a vector equation, you can just take the x and y components and separate them out into two separate equations. Let's do one more simple example, and then we'll talk about why would you prefer one versus the other. So you know that, let's start on this side, you know that cosine t sine t describes simple circular motion. This would be motion centered at the origin, radius 1, going anti-clockwise. So again, I could just package those together into a single vector, take x here and y, so cosine t sine t, and now it's a vector that describes the same motion. If I wanted to make the radius of the circular motion larger, for a vector you can think about it this way. I'd place a 3 on the outside because you know that scales the length of the vector. That's the same as if I had distributed it inside, like this. And that would be the same as if I put a 3 out here and a 3 there, because I took the x component, put it as the x equation, y component to the y equation. And then if you think about the meaning of 3 on this side, it's a scale factor just on the x coordinate and a scale factor just on the y coordinate. So here we're scaling both at once because we're scaling the entire vector. Once you distribute it in, you can think about it as scaling the two coordinates separately. Okay, so let's think about why would you choose to think about something parametrically versus as a vector. The main advantage of vectors is that it's easier to think about a complicated motion being broken down into the sum of some simple vectors. So for our original ball rolling example, if I want to write an equation for the path of that point on the perimeter, as the ball rolls, I don't have a good way of thinking about how do I describe the x-coordinate, because there's a lot of different things contributing to the x-coordinate. But for vectors, I can think about it as the vector sum of a stationary vector that just points straight up to the center of the ball, rather to the height of the center of the ball. Another vector that scales horizontally, describing where the center of the ball is as the ball translates to the right. And then a third vector that just rotates as the ball rotates. Am I rotating in the right direction? Yes. So let me write the 3 separate vectors, and then we'll think about what does that look like if you're going to rewrite them parametrically. Okay, so let's assume that the radius here is 1. So in that case, this vector just points straight up 1. My rotating vector, again, because my circle is radius 1, is going to have no scale factor out here, or rather it's a scale factor of 1. I've chosen to have rotational speed, or rather I've chosen to just put t on the inside here, and so then you could ask, well, how long does it take to make a full rotation? Because the angle needs to be 2 pi radians to make a full rotation, that means when t equals 2 pi, I will have made a full rotation. So it takes 2 pi seconds for me to go all the way around once, And so now we can think, well, how fast do I need to translate horizontally? You can think about this as my speed. Oh, I need to multiply by t in here. If you think about my horizontal speed, it's like distance traveled divided by time it took. So I guess think about it this way. If I plug in 2 pi as t, that means my horizontal distance will be 2 pi. That makes sense because that's the same as 1 full circumference, because the circumference is 2 pi times the radius is 1. So if I roll 1 full circumference, I will have gone 2 pi, and so that all checks out. So this is now a correct set of vectors to describe the movement of that point. If I wanted to package it parametrically, we can just take all of the x-coordinates. So here's 0, here's t times 1, and here's cosine t. So I'm just going to rewrite it here. So I've got 0 plus, I'm going to distribute the t in, so that'll be t, and then here I have cosine t. Here for the y-coordinates, I've got 1 plus t times 0 is just 0, plus sine t. It's a little bit silly to write the plus zeros, so that's just t plus cosine t and 1 plus sine t. Okay, so, it's a lot easier to think, like I said, about this movement if you break it down into separate vectors you can describe using your geometric intuition. I don't have a particularly great way of just jumping straight to the x-coordinate equation in a parametric form. But as you can see, you can always write your equation parametrically if you just combine the x components and combine the y components. So I would say choose vectors if you know you need to break the situation down by combining simple movements into a complex one. Would you ever want to just describe something parametrically instead of with vectors? Let's pretend that I have some fancy equation for some particular path I want to move along. It'll be regular x and y. You might choose parametrics if you want to be able to think about the x-coordinate separately from the y-coordinate. So let's pretend I want to start at a particular x-coordinate at time 0, and then move left at a particular speed. So I want to end up being down here at like time equals 11 or something. Let's actually put some points here. So let's say this is x-coordinate of 12 and this is x-coordinate of 5. So it might be hard to think about this in terms of vectors, but if I can separate out the x movement separately, I can try and describe just the position of the x-coordinate as time changes. And I can forget the y-coordinate entirely. So if I think about a graph here, if this is now time, and this is my x-coordinate, at time 0, I want to be at an x-coordinate of 12. So that's that point up here. And then at time 11, here's time 0, at time 11, I want to be down at an x-coordinate of 5, down there. And if I want my horizontal movement to be a constant movement, I could connect these with a linear function. If I wanted it to involve some acceleration or deceleration, I could make a square root function or a squared function or some other nonlinear function to connect those 2 points. If I can just write this linear equation, that's now my x-coordinate. That's now my x of t equation. And then if I know some equation involving x's to calculate y here, I'll just take my x equation and plug it in to get my y equation. So, to summarize, vectors are when you want to break a movement down into the movements of simple vectors. Parametrics would be if you need to think about your x motion separately from your y motion. I hope that this was helpful.